at the end of the clock cycle, that is at the T2, the master stores the data on data lines into its input buffer if it's a read operation. So just you recollect guys, that is, in your bus cycle we started at T0, T1 and T2. T2 was an ending point. What happens at T2? T2 is the end of the clock cycle. At the time, the master stores the data onto the data line, so data on the data lines into its input buffer if it's a read operation. That means whenever a master reads something from a slave, then at the end of the clock cycle, that is at a T2 time incident, whatever the data that was presented on the data lines, that was received by the master and it is copied into its internal buffer register. That operation what we can call is a read operation. Here important thing is strobe. The meaning of this strobe means to capture the values of the data and store them into a buffer. So here what a master can do is, the master stores the data on the data lines into its input buffer if it is a read operation. Then what's the meaning of this strobe? Strobe means to capture the values of the data and store them into an input buffer or internal buffer. That is the meaning of strobe. When data are to be loaded into the storage buffer register or internal buffer register, the data should be available for a period longer than the setup time of the device. So once you receive the data from the data lines which received from a slave by your master, the received data copied onto internal buffer register. Once the data was stored onto the internal buffer register, that will be stored in it in a longer period of time which is greater than or longer than the setup time of the device itself. Here the device, in a sense, it is either master or it is a slave. Why? Because if it is a master, if it receives the data, then it will be act as a master. The device here is. Once the master sending something to a slave, then here the device itself is nothing but a slave. So once the data was taken by your master or slave which is present on the data lines, it is copied into its internal buffer register. It will be maintained in that internal buffer register a longer period of time which is greater than the setup time of the device itself. Right. Hence the width of the pulse, that is a T2 minus T1, should be longer than. Just you recollect guys, at T0 time incident, a master places an address as well as a command signals over the bus. At a T1 time incident, the concerned devices which are connected to the bus, they are receiving the addresses. The received address, they can go and decode them and they can understand what are the commands which are issued by the master. So for that it takes certain time, that is at a T1. At T2 time instant, what we can say is the data transfer operation was finished. That in the sense, already the master or a slave it placed something over the bus that can be captured by other device, that may be slave or a master. So here the difference between the time period, that is a T2 minus a T1, that is the width of the pulse T2 minus T1 should be longer than the maximum propagation time of the bus plus the setup time of the input buffer register of the master. So here I am talking about a master in the sense the master collects the data from a slave. So for better understanding, I give a small diagram for this. Let you can assume this is some bus. So for this bus, different devices are connected like this. These are N devices. So this is a device 1, this is a device 2, and this is device N. So these are devices can communicating with each other with the help of this particular bus. So these devices are connected to the bus like this. Fine. So here important thing, the time difference between T2 minus T1, it should be longer than two important things. One is maximum propagation time. For example, So if I want to transfer data from this device 1 to device N, it takes the longest time because the distance between this device 1 and device N is too far. So to transfer data from D1 to Dn, it takes much more time compared to the data was transferring from device 1 to any other device which is connected to the bus. This is the one important parameter. And the second important parameter is the setup time of the device. For example, this device 1 want to transfer something to device N. So how much time this device N will take to ready to accept the data from the bus. So that what we can call is the setup time. So what we are saying clearly is at a T2 time incident, whatever the data that was presented over the bus that can be received by the either master or it can be received by the slave, that is depends on the operation what we are going to perform by using the bus. So here this time difference T2 minus T1 is purely depends on the maximum propagation delay between the devices which are connected to the bus as well as the setup time of the device, because the setup time of the input buffer register of the master. For example, here our operation is master receives something from a slave. Let you can assume this device 1 is a master and device N is a slave. Here our operation is this master wants to read something from the slave. That incident, this slave put a data over this bus that can be received by this master. So in that case, the received data was copied onto input buffer register. For doing of that, it takes certain amount of time. That time here we consider as a setup time. So the period T2 minus T1 depends on these are two important parameters. One is the maximum propagation time of the bus plus second one is the setup time of the input buffer register of the master. Yes. Next, the above timing diagram, that means what we already seen previous case. So this is our timing diagram. So this is a T0 and this is a T1, this is a T2. Once you are observing this, we have a clear cut edges. This particular timing diagram is idealized timing diagram because here we are not talking about rise times as well as fall times. So in this case we are getting sharp edges. Here we are getting a sharp edges. So it is an idealized timing diagram for a data transferring over the bus. So that is the meaning of here that statement is. So here the above timing diagram is an idealized representation of the actions. Signals do not appear on the bus as soon as they are placed on the bus due to the propagation delay in the interfacing circuits. So what here the meaning of this? The signals do not appear on the bus as soon as they are placed on the bus due to the propagation delay in the interfacing circuits. We know that the I/O devices we are not directly connected to the system bus. Those are connected through the interfacing circuits. So this is a valid point. That is, the signals do not appear on the bus as soon as they are placed on the bus due to the propagation delay in the interfacing circuits. Yes, it is true. Next. So the signals reach the devices after propagation delay, which it depends on the characteristics of the bus. Yes, it is true. Yesterday we clearly mentioned that. That is just now talking about the bus data transfers. The data transferring over the bus. How fast we are transferring data from one device to another device. That is depends on the speed of the bus as well as the electrical characteristics of the bus. So here the signals reach the device after a propagation delay, which is purely depends on the characteristics of the bus. So if you observe this, friends, here my signals are not idealized. Here I consider the propagation delays. In previous case, this address and commands are placed at here itself. But now it takes certain amount of propagation delay. Why we are getting this propagation delay? One is because of the speed over the bus as well as the setup time of your interfacing circuits. Because of that, we are getting this propagation delays. So that is the important thing. Next, data must be remain on the bus for some time after T2 equal to the hold time of the buffer. Yes, it's true. See here friends, the data must be there after T2. This is the T2, right? So the data still be there over the data lines. Because your interfacing circuits take certain amount of time to capture the data over on the data bus, and it will be copied on its internal data register. So for that it takes certain amount of time. That time what we can call is hold time. So that's why the data over the data bus, it must be there after T2 also, because in order to hold the data which is there on the data bus into the internal register of corresponding devices, for that case it takes certain amount of time. That time what we can call is hold time. Fine. Next, the data transfer has to be completed within one clock cycle. If you see our timing diagram, what we can understand is our entire data transfer was happen only in single clock cycle. That means in that timing diagram we have only T on period as well as T off period. So our entire data transferring between a master and a slave was finished in a single clock cycle. But coming to the reality, it can't take a single clock cycle, it will take multiple cycles. Let's wait till we can go and see it. The clock period T2 minus T1 must be such that the longest propagation delay on the bus and the slowest device interface must be accommodated. So here important point is, what is the time period? That is T2 minus T0, which is nothing but our bus cycle or complete clock cycle. So this value must be in a way, such a way that we have to consider the longest propagation delay. What is the longest propagation delay? The time taken by the bus to transfer the information from the first device to the last device, the devices which are connected to the bus. For example, you can assume this is the first device and this is the last device. How much time the bus will take to transfer data over these lines from this end to this end? How much time it will take, that we consider as longest propagation delay time. So this is one thing you have to consider. And second thing is, all these devices speeds are not same. These are the interfacing devices. Just you can assume these are two I/O modules or an I/O interfaces. And these interfaces are connected to different I/O devices like this. Based on these device speeds, these interfacing devices speeds are decides. So here this interfacing device is based very less. Now if I want to communicating with this device with this, definitely here I have to consider how much time this slowest interfacing device took to take an action over this bus. So that is also we have to consider to decide the value T2 minus T0. Because T2 minus T0 is our complete bus cycle or it is complete clock cycle. In order to decide the time period, I consider two important parameters. Parameter 1 is the propagation delay, the longest propagation delay. That means how much time our system will take to transfer data from first device to last device. That is number 1. And number 2 is the devices which are connected to your bus. Those devices speeds are not same. Some of the device which can be operated at a very slower speed, we have to consider the data device point of view to decide the time period T2 minus T0. That is the meaning of this. And here important thing is, it forces all the devices to operate at the speed of the slowest device. While if you are doing a data transfer over this bus, I have to go and focus on the slowest device. For example, this device can be operated at a very lower speed. And make all these devices, they can also operate at the same speed. Why? Because whenever a device want to communicating with that slowly operated device, then it takes much more time. If this device can be operated at faster speeds or higher speeds, and this device can be operated at lower speed, I was unable to provide a communication between this because this is a synchronous serial communication. In synchronous serial communication, the source and the destination or a master and a slave must be operated at the same clock. That means the host can be operated at a same speed or same phase. So, what are the devices I was connected to this bus? Out of all those devices, which device can be operated at a slower speed I have to take care of that device. Based on that device, I can go and make a remaining device also can be operated at same speed. That is the important thing. Right. Next one. The processor just assures that the data are available at a T2 in case of a read operation or are read by the device in case of a write operation. So here there are two operations, guys. One is read and second one is write. Listen carefully. What is read? The read is used to transfer data from slave to master. Transfer data from slave to master by using bus. Second one is a write operation. In this case, the information was transferred from master to slave. In our timing diagram, I have three different timing points. One is a T0, second one is a T1, and third one is T2. So this is an initial point, this is an initial point, and this is ending point. Initial and this is ending. Yes. So here what I am saying is, in my operation is read. Let you can assume in this my operation, this master is nothing but a processor or a CPU. For this case, here a master is nothing but a processor. So for read operation, what a processor can assume? The processor assume that the data are available at T2. Yes, is it true? Because of from T2 onwards, at T2, it is very clear. The data definitely presented on the data lines of a bus. In a T2 time incident, the master can go and take a data which was present on the bus that is copied onto its input buffer register. So here what I am saying is for read case, master is a processor. That's why a processor just assumes that the data are available at T2. That is for read case. If it is a write case, what happens? Instead of data received by the processor, now data was received by slave device, because here the data was transferring from master to slave. So in a write operation, what happens is from T2 onwards, the data was available on the bus that can be received by the slave device, and it will copy that one into its internal input buffer register. That is the meaning of this. And here there is a chance. Sometimes the devices cannot perform its operation. Sometimes the devices miss the operation, and sometimes the devices can't respond for the operation. To face this type of difficulties, we took the help of these control signals. What's the meaning of this? For example, this is device 1 and this is some device N. Both are connected to the bus. So this is a master and this is a slave. If the master sending something to the slave, sometimes the slave can't respond for the information which is transferred by the master. That is one thing that may happens. The second thing is, this device can't perform the task which is assigned by the master. For example, the master wants something from this, but this device can't send any information to master. That means this device can't respond for this. These are the two different problems you may identify in this data transfers. In order to overcome that, what we do is, we took the help of control signals. These control signals serves two purposes. So in that, what the first one? Inform the master that the slave has recognized the address and it is ready to participate in a data transfer. So one control signal, one variety of control signals was used in this data transfer is, the slave device informed to the master about, I received the address which is issued to me, as well as it sends the information to the master about, I received the commands which already issued to me. I recognize the address as well as the command words, and I was ready to participate in data transfer. That type of information that can be provided by slave to the master. In that case, the master have a full clarity about, yes, my slave is ready to respond for my commands. My slave is ready to participate in data transfer. That information can be get by your master once the slave send that information to master with the help of these control signals. And second one is enable to adjust the duration of the data transfer operation based on the speed of participating slaves. The second thing, I already told you that the devices which are connected to the bus, all those devices must be operated at the lower speed, the speed which is operated by the slowest device which was connected to the bus. Generally, some device can be operated at a higher speed and other device can be operated at a lower speed. But here important thing is the higher speed device must be reduced its speed in order to match or synchronizing with the second device which can be operated at a lower speed. That means here we have to enable and adjust the duration of data transfer operation based on the speed of participating slaves. It is very, very important. So these two are very important. Number one is the slave has to send an information to master about receiving of an address as well as the receiving of commands, and it is ready to participating in a data transfer. That is number one. And number two is it is unable to adjust the duration of the data transfer operation based on the speed of participating slaves. So with the help of the control signals, I can go and get these two types of informations. With the help of this, there is no chance for me. The communication must be done in an effective way in this synchronous serial communication. So synchronous communication. Yes. And next one is, I already told you that data transfer spans several clock cycles instead of just one clock cycle. In the first two timing diagram, what we can understand is our entire data transfer operation is performed in a single clock cycle. But in coming to practicality, it is not possible. So maximum cases what happens is the number of clock cycles that may be n to do a particular operation on the bus itself. So here I use multiple buses, so multiple clock cycles. Here I was using total 4 clock cycles to do same data transfer over my particular bus. In that case, again I issuing an address, I issue command signals, and later based on the command signal either I transfer the data or I may receive the data. And finally, the slave ready signal, this is a control signal which informs to the master, I successfully did what all the operation that was assigned to me. So this is another interesting thing. So here the slave ready signal, in previous timing diagram we saw that the slave ready signal, what is slave ready signal? Generally the slave ready signal is an acknowledgement signal. The slave ready signal is an acknowledgement signal from the slave to the master to confirm that the valid data has been sent. Again, here also our operation is, our assumption is, our operation is read. That means master needs something from a slave. So whenever a slave successfully transfer a valid data to a master, it will inform that information by sending of this slave ready signal, which is an acknowledgement. You can take it another way if your operation is right. If your operation is right, once you are sending an address as well as command signals, successfully it receives that address as well as command signals, and the devices are ready to participating in a data transfer operation, it activates this slave ready signal. Then your master identifies that my slave is ready to accept my data. Then your masters transfer the data to the slave itself. So that's why the slave signal is act as acknowledgement signal, and the signal is helpful to us to do both the read as well as write operations without any difficulty. Next, depending on when the slave ready signal is asserted, the duration of data transfer can change. Yes, absolutely. Once you are sending an address, once you are sending a command signals, in case of a read operation, after certain amount of time your slave can respond by activation of slave ready signal. According to that, the data transfer taking place on the bus. So here important thing is, depending on the slave ready signal, is when it was asserted or activated, the duration of data transfer can change. And next, the clock signal used on the bus is not necessarily the same as the processor clock. Because the processor has certain clock frequency, and here our bus has certain clock frequency. In case of synchronous bus or synchronous bus protocol, your bus has certain clock signal, it has certain frequency. That frequency may not be equivalent to your processor clock frequency. Generally, the processor clock frequency is very high compared to the bus clock frequency. That's why the last point is like this. The processor clock is much faster than bus clock. So here one thing is very clear, friends. In case of synchronous bus or synchronous bus protocol, the master and the slave must be operated at the same clock. They must be operated at the same frequency, or they can operate it at the same phase. So in that case, we have to take care of the devices which are connected to the bus, which can be operated at a lower speed. We can go and make our remaining devices also may operate at the same speed. The device which can be operated at a lower speed. So that is very, very important in case of this synchronous serial communication or synchronous communication. So I hope you understand what this synchronous bus or synchronous bus protocol. Thank you for patient listening. In the next class, we'll go and discuss about asynchronous bus or asynchronous bus protocol. Thank you. Thank you very much.